Hello everyone, my name is Bilal Kaçar. I'm a student in Physics 101 course and I study at Bilkent University at Computer Science Department. Today I'm gonna present my lab project where I conducted an experiment to test Hooke's law and determine the spring constant of a coil spring. Let's begin with the theory and purpose of this experiment. In this experiment, I aimed to verify Hooke's law and calculate the spring constant. Usually denoted by K, Hooke's law states that the force applied to the spring is directly proportional to its extension, F equals Kx, where F is applied force in newtons, x is the extension in meters, and K is the spring constant in Newton meter. The materials I used were a coil spring, a hanger, a roller, and three different masses: 187 grams, 344 grams, and 538 grams. The spring was suspended vertically from a fixed support, and I gradually added the weights to observe how much the spring extended. I first measured the initial length of the spring without any weight. Then I attached to a mass of 187 grams and measured the new length. After that, I used a heavier 538 grams mass and recorded the further extensions. I also performed an additional trial using 344 gram weight, which is included in my calculations even though it's not shown in the video. For each mass, I calculated the applied force using the equation F equals mg with g equals 9.8. Then I measured the extension x in meters by subtracting the initial length from the stretched length of the spring. Using these values, I calculate the spring constant analytically with k equals F divides x. The results were 40.67, 39.19 and 37.64 newtons per meter. And their average gave me an estimated spring constant of 39.17 newton divided meter. I also plotted a force versus extension graph using Excel. The resulting trendline equation was F 36.16x plus 0.22 with r square equals 0.996. This high r square value shows a strong linear relationship which confirms that the spring followed Hooke's law accurately within the tested range. The small difference between the analytical and graphical values of K can be attributed to minor experimental uncertainties, such as slight errors in measurements, mass tolerance, or reaction time delays when recording the length. Overall, this experiment allowed to confirm fundamental law of physics through simple tools and careful measurement. Thank you for watching.